Hello everyone, my name is Devansh and we are back with another question. And this time this question is like pretty much like I've found it pretty much interesting, doable, but also it had a very great mathematical concept. So I thought of actually recording it. I'll be honest, I've already solved this question, but not on my own. I took the help of ChatGPT, uh, and I'm actually not quite proud of that. But the thing is that I actually found out a very new way of thinking, an identity basically, uh, which I did not know before, but now I know. Uh, Okay, so that thing is, let me just first tell you guys what this question is all about. So this question is 2244C, and name is Stepan and permutation Stepan. Okay, so Stepan found a permutation P of length n, and of course he decided to sort it. To make the process more interesting, he chose two positive integers x and y such that x plus y is less than or equal to n, and defined a rule for swapping the elements. So in one move, Stepan can choose two indices I and j, where I and j belongs between inclusive 1 and inclusive n, and then he swaps pi and pj if at least one of the following conditions holds true. So if only one of the following conditions holds true, and that is the first condition is either I minus j should be x or I minus j should be equal to y. At least one of them. If both are holding true, it's very well, but at least one of them should be true. Okay, so Stepan wants to know whether it's possible or not to sort the permutation. Okay, help him answer the question. Okay, now without wasting any time, let me just jump to the solution. And I've already found out the solution, but we'll derive it from scratch. Okay, don't worry. We'll derive it from scratch. Okay, let's say, let's say our permutation is 5 4 3 2 1, and we need to, by the way, in the question it is mentioned that we need to sort it in the ascending order. So what order will it be? It will be 1 2 3 4 5, and surprisingly, if you notice, this is actually their indices, right? So the index of 5 is 1, the index of 5 is 1, index of 4 is 2, index of 3 is 3, index of 2 is 4. So the index that each pi element of every permutation has, the same index should be at the in should be in the place of pi, right? If we want to sort them in the ascending order. Okay, so that's the very first thing that we found. So if we assume the zeroth indexing, so these indexes will look like 0 1 2 3 and 4. And so after sorting it should be 1 2 3 4 5, right? So uh, after this we'll have our input as x and y are already given. So all right, so you don't need to worry about finding x and y. We already know x and y. We already know the permutation. You just need to say yes or no if it's possible to sort them or not. Okay? So if we assume zeroth indexing, what can we say? We want this 5 to be somewhere here, right? We need this 5 to be somewhere here, right? In order to do so, what we need to do is that we will say that, okay, uh, we will take the I plus 1th index. So basically this represents 1, and this is the actual indexing of the permutation. If we don't talk about in terms of array, in array it starts with zeroth indexing, but if we talk about the actual indexing that we do in real life, we don't say this element is at the zeroth position. We say 5 is at the first position, 4th is at the second position. So that's how we do in a real life, right? So if we say this is the thing 1, and then we add x and y are already known, and so let's assume x to be 2 and y to be 3 as our first test case is this. Look at our first test case. This is the thing. The first test case is 2 is the first x and 3 is the y. So the one, so this 5 should be at this place should be here, right? So we need 5 to move from here to there. In order to do so, the initial position of ith element plus will have a linear combination of a times 2 plus b times 3 will result in its final position, right? That we want to do. Like we want to that's the only way to swap the things. What can you do? You can either, what I minus j mod actually means, or I minus j mod equals to y actually means, what does it mean? It means that you can only swap either, if you're taking this element, you can only swap between this, or you can only swap these. You only have two options right now. Either you swap 5 with 3, or you swap 5 with 2. No other option you have actually. Okay. Once you do that, let's say you swap, what do? You swap with 3. So 5 comes here and 3 comes here. Now you can only swap with 1, right? Because of this condition following, if that's x is 2 and y is 3. You get my point? So that's how we are doing it. So we ask this one question: the initial position is 1, that is a 5, the initial position is 1, 2 times a plus 3 times b, the final position that we want is 5. So 2 plus 3b is 4. So if we put b0 and a1, a2, sorry, our answer will be yes. So that means that if this b0 and a2 means that if we use I minus j equals to 2th condition, if we use this condition 2 times on 5 swapping, so that's what we did, right? We used I minus j equals to 2 with condition 2 times. We first did with this, we swapped it, 5 came here, 3 came here, then again we did this, we swapped with the second element from this place, and then then 5 came here and 1 came here. That's what we did, right? Exactly. If we talk about 4, 4 is at place 1. So, sorry, that's not there. 4 is at place 2. So, 2 plus 2 times A plus 3 times B, and we need a final position at 4, right? So, we need 4 to be here. So, we need a final position to be here. So, we have 4. Now, 2A, 3B, and equals to 2. So, if B is 0 and A is 1, that is, if we use this condition, I minus j mod equals to 2, only one time we need to use. and that too swapping here to there, right? So 2 will be here, 4 will be here, and we'll be good to go, right? So this that's all it means. Now, what if it was like this? 5, 4, 3, 2, 1, and we needed 1, 2, 3, 4, 5, 6. That's the ascending order, right? So talking about 6, and x is 2, y is 3. Talking about 6, what can we say? Its initial position is 1, and we need a linear combination such that its final position becomes 6. Okay, so 2a plus 2a plus 3b is 5. So now a is 1 and b is 1. In this case, what does it mean? It means that we need I minus jth equals to 2 condition. We need to use one time, at least one time, and we need I minus j equals to 3 condition, 3th condition, at least one time, and not at least exactly one time. So how are we going to do it in any order? Order doesn't matter. So if we choose the to swap it with the third position from this index, we'll swap it with this. So here will be 3, here will be 6, right? Then after this we need to use this condition. So we'll swap it with the second element from this position. So 1 will be here and 6 will be here, and hence we will be here, right? That's the thing. So now you can use something like this too. Okay. Okay. So you can actually see that you can have a multiple of 2, you can have 5, you know, 5 places jump, you can have a jump of, let's say, uh, you can have a jump of 3, you can have a jump of 2 with a combination. Can you have a jump of 1? Let's see. Like if we want 6, 5, 4, 3, 2, 1, and we want 6 to be here. Can you have it? Can we do that? Of course we can. How? A and B can be negative 2, right? So if we just simply say that, you know what, the initial position of 6 is 1. If I add 3 and then remove 2, that is, if I say B is 1 in this condition, in this condition, if I say B is 1 and A is minus 1, we'll have our answer, right? We'll have our answer. We'll be at the second position because that equals to 2. You're getting my point? So what we can say is that, you know, we have this, we have this, uh, we can generalize the equation to be something like, if we find the GCD, and that's a Benzout's identity that states that if an integer is written as a times x plus b times y, then this a times x plus b times y will be multiple of GCD of x and y. That means if we say G is equals to GCD of x comma y, then G times something beta, and that is an integer, will be equal to a times x plus b times y. And this, if you remember, a times x plus b times y is nothing but this initial position and final position ka difference. So, okay, that is the difference of final position minus initial position, right? And that will be a mod. Okay, so final position is what? Final position, if you look, 6, 5, 4, 3, 2, 1. 6 must, the pi element is actually the final position, is actually the final position, isn't it? Because we need 6 to be here, right? And that is the sixth position. And actually this I plus 1, plus 1 because of the zeroth indexing, because I in the array stands for 0, but we want it to be 1. So I plus 1 is the initial position. So now our answer will be g times beta is equals to uh, pi minus I plus 1 commod. And if beta is some positive element, is positive, and that will of course be positive, but it's an integer, then yes, you can have it. You can have it, of course, you can have it for every element. For every element, this must hold true. Okay, all right, let's code it now. If you didn't understand it, please rewind it and check again what it all means. So we have an n x y, then input of n x y, then we have a permutation here, right? So it's nothing but int p n, and for int I equals 0, I less than n, I plus plus, c in is pi, wait. Okay, uh, we need to also find g, where g is nothing but gcd of x comma y, and then we have solve function where it is void or not in this void solve. Okay, my bad. We'll have all these inputs here, and now for int I equals 0, I less than n, I plus int difference, that is absolute of what, pi minus I plus 1. If and then int beta, b stands for beta, is diff divided by g, then if g times b equal to diff, if it's an exact integer, because int gives a round off value which is less, so less than the actual value as of round off. So if that's equal, continue, else see out no, and then return, else see out yes, and then return. And it is all the test cases are passing, right? We really simply submit it, and let's hope it passes. Integer overflow, no, right? I don't think so. There should be integer overflow because n is 10 2 into 10 to the power 7 and 5. Accepted. Okay. Thank you for watching the video. I hope it is helpful. Thank you.